you had some questions on reading guide 1. The only one that most people have an issue with is what's alchemy. Maybe what's, or why does it have a negative connotation? Kyle, what you got for me there? Give me something that you took out for, I think that was number 4 on the reading guide 1.
This one I did not get.
Well, what's else? This is number 4 on reading guide 1. We had alchemy mentioned in the first video you guys watched, I think, Tuesday? Oh gosh, was it Monday or Tuesday? Chloe, what you got?
I said it was the early form of chemistry.
It was the early form of chemistry and science in general. But why does it have a negative connotation? Emily?
I think it's kind of both sides from that, right? But some people see it as like more medieval.
Right, it's medieval, and maybe it didn't have a lot of logic behind it, a lot of support from the community. Some people thought it was related to magic. So it didn't have a lot of credibility, basically, because they didn't feel like it was a pure science. So the negative connotation just means it has a negative meaning to it. So alchemists were not as well respected as true chemists and other scientists are today. But it's obviously where we got started and then how we've kind of advanced from there. Any more questions on reading guide 1 that you weren't sure on? Speak now for all keys, people. Okay, reading guide 2. Reading guide 2. What's the question we have, Jillian?
It was numbers for reading. We had to make a chart.
Okay, just like a little float. Do you know how to make like a little float map?
Yeah, I didn't look in the book, and I just there was a chart.
That's fine. Okay. So you would have had something similar to matter, and then broken down into what and what?
Pure substances and mixtures.
Pure substances and mixtures, and then you maybe went further to talk about homogeneous and heterogeneous and elements and compounds. Yep. So any questions on the little chart you should just describe here or depicted? Okay. There were 5 questions on reading guide 2. Yes, sir.
In the chart, did you want a definition for homogeneous mixtures?
So it doesn't ask for definitions, but it does say describe or explain the difference. So that might be your explanation of the differences.
Okay.
Okay. All right. Seriously, any other questions on reading guide 1, 2, questions? Yeah.
What was the map?
The map
On number 3?
That's what I just drew here. I just gave a brief description of it, but it was describing how matter as a whole can be segregated into 2 different categories: pure substances and mixtures. And pure substances had 2 further subcategories, which were what and what? Elements and compounds. And the mixtures were. All right, so homo and hetero, because there's a one that's the same throughout and not. So we're going to talk a lot more about stuff in chapter 1 and 2 later. But if we are good with reading guide 1 and 2, make sure that you have your name on it. I have a couple people with no names yesterday. And let's go ahead and pass them up and over to get. Okay, I'm going to do this. We're going to take like a 5-minute quiz on stuff that we've already talked about so far this unit. And then we're going to move on to our next chapter. Pass them up and over, and if they're not doing like, about 30 seconds, and I'm not going to take them people. Yeah. Who needs a stapler? Stapler? This one's going to come back. Okay. And raise your hand if you need a calculator. Alright, do we have to use that calculator right now? Oh, great. Okay. Alright, so let's go ahead and do this density question. Yeah. Let's use a calculator. Hold the stapler. Where's that? Okay. So, density, we know how to describe density. We're just talking about density in general, like how would you describe it? Probably a relationship between mass and volume. maybe how compact things are, how densely packed would be very dense, very loosely dense particles that would be less dense. And so that can also describe how it will float and sink in water. There's lots of things we can put this in context with. But today we're going to be moving on to something that's called dimensional analysis. So I want to show you density and how maybe you might solve it now versus how you might solve it after you learn dimensional analysis. So with this question, who feels comfortable, go ahead and tell me, how did you solve? Rishi.
So basically, I just plugged in the numbers for in the formula. So density would be 13.2.
So density was equal to 13.2
Yeah.
grams per centimeter cubed. Okay.
And then it would be equal to m divided by 125.
Well, is this the volume or is this the mass?
Oh, sorry. Yeah, that's the mass.
Okay. So he's saying this is the density, and you're saying that's equal to mass over volume, right? So the mass was 125. Oops. That's a 5.0 grams over what? So would you put like X down here? Okay. So for me, this is called setting up a proportion. Give me a thumbs up if that's what you thought to do. Was set up a proportion. All right, so proportions are generally okay, and you'll use them in a lot of other classes, but maybe not as much in chemistry, because I'm going to show you how density is actually something called a conversion factor. Who watched the optional video last night on dimensional analysis? Okay, you're ahead of the game, because after this, we're going to start talking about that, because what you should recognize is that when things are a conversion factor, they're actually saying that something is equal to the other thing. 13.2 grams of mercury is equal to a space centimeter times centimeter times centimeter, so 1 by 1 by 1. So it's saying that if I had a block of mercury that was 1 centimeter by 1 centimeter by 1 centimeter, it would have 13.2 grams of mercury in it. Tomato, tomato, they're the same things, but that's saying. So that's a conversion factor. So I'm cool with you solving it like this for now, but eventually we're going to transition to, and Rishi, what'd you get? Did you try this yet?
Oh, yeah. I got like 9.46.
9.46. That sounds right, yeah. So 9.46, I have my answer over there. I'll go check. Centimeters cubed, right? And how did you solve this?
So,
How did you mathematically solve it?
oh, so basically I just, I did 13.2.
Okay, so you multiply by x on both sides, right? So you brought the x up over here and multiplied by x over here, and you canceled out the x's here, and then you technically took the 13.2 and you divided it on this side, right? Okay, so it's 125 divided by 13.2 is 9.4. Question?
I think it will be 9.47 because like the 6 rounds up because there's a 9 after it.
Okay, so give me give me like 3 or 4 decimals.
9.46 96
9.46.
96 9.
6 minutes.
Okay, so I'm gonna stop there for a second. So we see that there are, and this is a division problem, of course. This is 3 sig figs, 4 sig figs, so 3 sig figs wins, and you're right to say the following. So 9, 4, and 6 do count, and that 9 does influence the 6 to get rounded up, so that would be 9.47, or yeah, 9.47. Okay, so good thinking on expanding your decimals and then rounding. But yeah, how we solve this? Okay, so for proportion, if you had x on the bottom and you're isolating x, I'm going to take out the units for us just to make sure we're clear on what this is. So 13.2, I like it when it like randomly pulls up stuff. There we go. So 13.2 is equal to 125 over x. So if I take all the units out, it clears it up. So if you're trying to isolate x here, you multiply x on both sides to get it out of the denominator. Because now x over x, since they're the same thing, they can cancel out. So then technically you have 13.2 x is equal to 125.0. This is like algebra 1, right? Solving for x. So then you would to isolate x further, you would then divide by 13.2 on both sides. So that's what Rishi said he did. 125 over 13.2 equals x, because this right here cancels out. Okay? So I'm going to show you guys how to do it via dimensional analysis later. Okay? So you should have a calculator out. We're going to take our like 5-minute, 6-minute quiz. Yes? Yeah.
We have like a number.
10.00. So your rules are decimals present, right? What does that mean? Start counting from the Pacific Ocean, which is on the left of the United States, to the side. And when do you start counting sig figs? First non-zero, and that's going to be the first number actually. And once you start, you don't stop. So you count 1, 2, 3, 4. 4 sig figs. But if you had like 1,000, like that, how many sig figs?
Wait,
1. 1,000 has no decimals. So there's an absence of the decimal. So it's absent. You start from the Atlantic, which is the right-hand side, and you start the first non-zero digit. Skip, 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 skip. 1.
So it's like if there was 10.00, it would be 4 sig figs, but if it was just 10 without anything, it would be 1 sig fig.
Because this is saying I'm really, really accurate. Because I'm like, I know 10.00 people, not just 10. Because you know that your instrument, whatever it was, had lots of graduations on it.
So what if your answer was like something like 1,000, but you have to have like more than 1 sig fig?
Then you would use scientific notation. So can you write 1,000 in 3 sig figs? Can you do that? Write 1,000 in 3 sig figs. I hear 1.00 times 10 to the third. Right, same thing. Tomato, tomato, same thing, but that's written to correct. All right, don't be scared. It's a low stakes quiz. It goes into a small portion of your grade, but the way I do quizzes are a little differently. It's an online quiz. I need you to pull out your phone if you have one. If not, I'll get it from you in a second. There are computers around. You guys are going to be logging onto a website called Socrative. So raise your hand if you do not have a device right now, so I can make you go sit at a computer. Now, you're going to log on to Socrative. So on Socrative, when you get there, it's going to tell you to, when you get to Socrative.com, it's going to say student login, and that's just at the upper right-hand corner. And then it'll say enter room number. Room number is in low. And so right now, I'm going to go ahead and turn it on, because right now it's got like a blinking red light that's like waiting for your teacher to start. So I'm going to turn it on, and it shouldn't take us very long. I'll come around and look at your screens. I'm going to go through some easy examples first. If I'm a little clicker. It has escaped me, but it's okay. So, the first couple are going to be some explanation-based slides. Well, I'm just going to have to do no, my stuff's gone, guys. It's not working. Oh, no. Okay. Don't fear. Okay, here we go. So, like I said earlier, density is a conversion factor because it is written as a fraction, an equivalency fraction. So, I'm going to show you how we walk through this with the terms given and unknown. So, I'm going to ask us to kind of use that consistently together. So, our question here is how many grams does 40.0 centimeters cubed of aluminum make up? Okay? So, the given, the factoid, the fact that's given is 40, or the starting point is 40.0 centimeters cubed of aluminum. We have this fun fact up here, 2.7 grams per centimeter cubed. We have that, but you'll notice that it's written as a fraction, so we call that a conversion factor. So our conversion fraction, as some people call it. So whenever we start with a question, we always start with the fact, the given, in our mathematics that we're showing out all of our work for. So I asked for you to show your work with me, because then that will remind you how you are expected to show your work on your own. So you're going to start with 40.0 centimeters cubed. Okay. Whenever we write these, we're always going to be writing numerators and denominators, numerators, denominators, numerators, denominators. Don't write it like this with a slash. Write it as a bar. All right? So my goal is to get from centimeters cubed to grams. Well, there's a conversion for that. It's called density. So basically what this is, thank you. This is same as saying 2.7 grams per centimeter cubed like this. But since I have this written in a fraction already, I can actually plop it down right here. So whenever I take this conversion factor, and I'm just going to go ahead and write it, I'm going to show you how this works first before I go further. 2.7 goes on top, grams. 1 centimeter cubed is going on the bottom. So you'll notice I've written this 40.0 centimeter cubed. I've written it higher to indicate that it's a numerator. I could go and put a 1 underneath it to really show I am the numerator and I'm the denominator. But I think if you write it high, you'll notice that, okay? So what do you notice about centimeters cubed? Where do you see it? You see it top and bottom. That means you can cancel those units. Only if the exact unit is on top and on bottom can you cancel that unit. That is the goal. You need to cancel units you don't want. I don't want centimeters cubed. My question's about grams. So, in the end, what's the only unit left? Grams. Yay! I've met my goal here. Now I need to calculate. So I need to pull up my calculator and do 40.0 times 2.7, since those are, you multiply across and you divide if a number's on the bottom. Well, both of these numbers on the bottom are 1, so don't worry about dividing. What's 40.0 times 2.7? 108. And what were the units? Grams. Okay, that's it, guys. That's how we can utilize density, which we already know a little bit about, as a conversion factor versus setting up a proportion. So earlier examples for warm-up was find the volume. This question was use the volume and find the mass. We can do it both ways. Did you have a question?
Would you have to round that?
No, that's the point. So at the end of our calculations, we always have to consider what? Sig figs. How many sig figs should this have? 2, because of this limiting one here. So round that to 2 sig figs. Say it again.
11.
108 to 11?
1.1
To the positive, right? Because you're going higher, right? So let me make it easy on you. Take this 108 and round it up. What would you round it to? 110. Don't change the number entirely, right? You're going to round it to just the next either up or down. Well, this is an 8. 2 sig figs here, but this 8 does influence that 0 to go up. So I round it up to 110. You can write it like this, or you can write it like 1.1 times 10 to the second grams. Notice that these two things are exactly the same. Either way is okay. Yes, ma'am.
Why did you round it up to 110?
Versus what? Because you can't round it to 11. 11 and 108 are not even close. Don't forget, rounding doesn't change the number entirely. It just modifies it a teeny bit. Don't change it from 10 to 100 or 110. So 2 totally different numbers, yeah.
So when you cancel out, you only cancel out the units, not the actual numbers?
Yes, good point. You only cancel the units associated with it, not the number associated with it. Yes.
And the 1 centimeter cubed on the bottom, that doesn't affect it, so you don't count that sig fig.
I see what you're saying. So generally, whenever we're considering sig figs, we're looking at the measurements given to us. So this is a measurement with 3 sig figs, and this is technically a measurement of 2.7 grams per 1 centimeter or per centimeter squared. I put the 1 there so that we would notice that it's the equivalency. Sometimes these could be more accurate, but at this point, that's all I was given. So I want you to ignore that sig. That's not considered a sig figure now, and I'll be more clear with that in the future. Okay. All right. So let's go down to this one. Density again is given to us single. Now this is our starting point. 40.0 grams. What are we converting to? So how much space, right? Space is volume, right? And we had 2 different units for volume. Milliliters or centimeters cubed. I'm going to say we're going to use centimeters cubed because that's what you can't see anymore, but that's what our density included above at the very, very top of this. So start with your 40.0. Justin, do you give me? Okay. We're going to start with our 40.0 grams of aluminum. Now, this conversion factor that we have way up high, right up here, I wrote it like this. 2.7 grams per centimeter cubed. Now, conversion factor is an equivalency. You can do whatever you want with it. You can keep it just like this, or you can flip the numerator and denominator. It is a tool to use for conversions. So I'm going to flip this and put 2.7 grams on the bottom and 1 centimeter cubed on top. Basically just taking this and flipping it upside down. The units that are within the number, though, have to stay with their number. So this is a tool now. And the only reason I'm doing this now is because in this very bottom question that we're working from, what unit do you think we want to cancel? Grams, right? So if I'm going to be canceling grams, the grams from the density have to go in the denominator. So I'm transporting this down here. 1 centimeter cubed and 2.7 grams. So using that conversion factor, I can now say grams, which this is over 1 again. If you need to write that for yourself, do it. This gram and this gram, gram and gram, can cancel. So mathematically, what do I need to do now? So 40 what? Divided by, right. So 40.0 is on top, and this is divided by, this is on the denominator. Do that for me. 40.0 divided by 2.7. 14.8. I'm stopping there. Okay. And what unit is this? Centimeters cubed is the only unit left up here that never got canceled. All right, so in accordance with sig figs here, I'm going to tell you guys again, 2 right here, so round this to 2. Sig figs. Say again? 15, yes, 14.8. That 8 does affect the 4 to round up, so 14.8 is close to 15. We're still in the ballpark here. All right, so this was an example with density, conversion factor of density. Anything with a fraction can be considered a conversion factor. We actually can make up our own conversion factors. If I said I have a kilometer, how many meters are in that kilometer? 1 kilometer. Say again? 1,000. 1 kilometer is equal to 1,000 meters. Okay? 1 meter is equal to how many centimeters? 100. Okay? A centi, like a century, 100 years. Centi is going to be 1,000 or 100. What if I said how many millimeters? How many millimeters are in 1 centimeter? 10. You know that just because you know how to read a ruler, right? Well, all of this stuff is just related to the metric system. King Henry dot drink chocolate milk. Got that from your video? Okay. Dot what? Say again? Not M. Hold on. King, if you need to write this down at the top of your paper, do it with me now. I'll have it later on, but here we go. King Henry died by drinking chocolate milk. Milk is what unit or what prefix? Milli. Dot micro. It's that funny U thing. Dot nano. Yeah. Dot pico. What's on the other side? Mega. Sorry, that's an M. All right, so this is like a big, huge number line. So here's how I can help you recognize these. Some of these are memorized because you guys have been exposed to this for your life. But, for example, if I wanted you to tell me that there were 1,000 meters in 1 kilometer, what you would do is you would see that K is kilo, right? In 1 kilometer, where's meter on here? Base, okay. Base is right here. That's meter, liter, and gram. Okay. Kilo is how many spaces away from base? 3. 1, 0, 0, 0. 1 kilometer had 1,000 meters. Do you see how I did that? Okay. So then let's do the other one. Let's do the centimeter one. Where's centi here? Okay, see? So 1 centimeter has how many millis? 10, because you only go over to the milli here. Okay, and let's do one more. How many micrometers are in a meter? So where do I put the 1? Here or here? On the base, because you always have one of the big one and lots and lots and lots of the little ones, the smaller you get. So there's 1 meter has how many micrometers? How many zeros? 1, 2, 3, 4, 5, 6. How many is that? 1,000,000. And who has time to write all those zeros? 10 to the 6, right? Don't write all those zeros. Anybody got time for that? All right, so we're going to be using this quite a bit. Here we go. Now I'm going to go through the ones that I feel like you need to. Let me scooch over to the ones that are on your paper. Do you see these on your paper? One-step conversion. This is, so we were working from the left-hand side for lecture notes one day. We're working from the right-hand side for the other ones. So I'm going to probably do 2 or 3 from each set right now to give you samples. And now when I say show your work like I'm showing my work so that we're working the same way. And this is how I expect you to show your work in your problem set, etc. I'm just moving on because we get out at 8. We get out at 8:55, okay? So I got to move. All right, so this is single-step conversions. Show what you're starting with and move on. Obviously, this is the number we're starting with, which is 3,500.0 milligrams. And what you can do is you can write this over 1, if you feel like that helps you recognize numerator and denominator. And I'm going to convert to grams, right? Well, I'm going to go ahead and put my multiplication symbol, and I'm going to convert it to grams. Now, this is easy because only thing you have to do is compare grams and milligrams. So comparatively, which is bigger? Grams. So King Henry died by drinking chocolate milk, okay? Where's gram at here? Space. So if I have 1 gram, how many milligrams are in a gram? 1,000. Okay, so you know 1 gram is 1,000 milligrams. Which one do I put on bottom? Say again? The milligrams, I want to cancel. This is your guide. This first unit always goes in the bottom because you need to cancel it out. Nobody wants that anymore. We're going to a new unit. So you said milligrams goes on bottom, and so that means what goes on top? Grams, and you said which was the one? The single gram, and then there was 1,000 milligrams in a gram. Now, I know you're going, I could just do decimal swoops, Miss Inlow. I know you could. I know you can go, oh, this divided by 1,000, 3.5000. But I'm having you do it easy with me doing dimensional analysis first with things that make sense to you, because when we move on to things that are new and foreign, you'll know your process. You should have a process for all problem solving. So in your calculator, you're doing 3.500 divided by 1,000. You should get 3.5. Okay, I hear grams. I'm going to put grams over here. And I want to show you that in these types of problems that just have a single measurement, right, so this 3,500 thing, that's our only measurement. This information over here, which is from our metric system, these are just metric conversions. This right here is not a measurement we have taken. This is just our brain working. This is the measurement we have taken. For these problems right now, I want you to look at the sig figs from the first one. So how many sig figs are here? 5. How many should this have? Sorry, give it to me. How many zeros? That's what I'm telling you right here. These right here, this is from our brain. We never actually measured that, right? Sig figs are always controlled by our utensils and things that we're measuring with, right? So that's the measurement we took for whatever, we were measuring something, obviously. That's our measurement. That's the sig figs we're looking at. This is from our brain. This is not what we're considering for sig figs. And I'll work with you guys on those because that's sometimes hard to distinguish. Yes?
So we're not going to round for these.
We are rounding to the appropriate sig figs from our first number. Yeah. So first number says 5 sig figs. This needs what? 2 more zeros?
Yeah.
Okay. That's the best we can do. Was 5 sig figs, 5 sig figs. And actually, there's no need to round in further. We're done. Yes?
So since grams was like the only thing that wasn't like canceled out, that would be
That would be the only unit remaining. Yes. Okay, let's go down to 3. Down to 3. So I'm going to work with micrometers. So write your first number, micrometers. Put it over 1 if you want. And we're converting to what? To meters. Good. Okay, so you have your big King Henry died by drinking chocolate milk, ... all that right there. So I want you to tell me first, before we even look at numbers, what unit has to go on the bottom? Say again, Darcy? Micrometers, because I don't want micrometers anymore. I want meters in the end. So micrometers has to go on the bottom in order for us to cancel it. And you said we're converting to what? Meters. So I know I'm putting meters on top. Now let's look at the number line, the big prefix number line. Tell me, which is the bigger unit? Meters. So meters gets a 1. It is the bigger unit. So how many micrometers are in that meter? A million, right? So can we write that as 10 to the 6, just because I'm not writing 6 zeros. Not lazy, efficient, okay? So 1 meter has a bunch of micrometers in it, a million micrometers. Does everybody see how we're getting this right here? The 1 always goes with the larger unit. The larger number goes with the smaller unit because there's lots of them. So then in your calculator, you'd be putting that number. The micrometers have canceled because there's one on top and one on bottom. So that number divided by a million or 10 to the 6, whichever way you prefer. And I'm hoping if your calculators maybe are in scientific notation, well, I'll do it before scientific notation. I think 0, 8, 4, 3, 4, 5, 6. Okay, so we can write it like that, or we can write it in scientific notation, meters. And you'll see there, how many sig figs here? 6, and there are 6 here. 8, 4, 3, 4, 5, 6 is off the board, but it's there. There we go. There's a 6 on the end. But right now, I know we're focused on sig figs all the time, but right now I just make sure you're comfortable with conversions. Okay? So give me a thumbs up if these 2 examples have made somewhat sense. Awesome. Metric is good with some. Some of us are still working. Okay. I'm going to go to 5. This is a double conversion process. This one's going to have 2 types of conversions. So, write down your initial given, which is 88 meters, and then do you see it says slash seconds? Write that as a denominator per second. All right, so I want you to see there are 2 different final units we're looking for. The first one is meter is going to have to be converted to what? Centimeters. And then, actually, no, there's not 2. The bottom one is 2. The second stays as second, correct? So don't touch the denominator. We're good here. That's going to stay with us the whole way through, meaning we're not going to cancel it. That's all that means. So your fraction you want to set up would be having what unit on bottom and what unit on top? Okay, I heard meter on bottom because you need to cancel meter. It's your guide. And what do you say on top? Centimeter on top, because that's what you want in the end, correct? Okay, you already know meter is going to cancel, but now you got to go back to your number line, looking at it in front of you. Which is the bigger unit? Meter. What does it get here? A 1. 1 meter has how many centimeters in it? 100. You guys look. You're looking at phase, and you look 2 zeros over, and you should see the C. That's 100. Okay, what unit cancels? Meters, and what units are left? So I hear centimeters are left and seconds are left, right? So in the end, we're going to have whatever 88 times 100 is. What is that? 8,800, right? And then what units? Centimeters per second. Because this centimeter number got canceled, neither did the second. And since there were only numbers on the numerators, you just multiplied across 88 times 100. Nobody needs to divide by 1 because that doesn't change our value. And this happens to have 2 sig figs, like this one over here started us off with 2 sig figs. All right, so canceling, canceling, canceling. That's kind of the way we're going here. Now, 6. This is the one that has 2 conversions embedded within it. So far, these have all been kind of one-steppers. So let's write this one as a fraction, showing your work as we go here. And I want you to tell me, what do you want to do first? Do you want to convert the numerator from grams to kilograms first, or do you want to do the denominator from milligrams to milliliters to liters first? So some people said milliliters, some said grams. I heard a lot of grams, so I'm going to stay with the numerator first. And I want to show you that you can cross from like one way over here and one way over here, and that's fine. So here we go. What do you know has to go on the bottom? Grams, because grams are here. You have to put grams here. And then I'm going from grams to kilograms, right? Because you have to compare the same type of unit, which are grams and grams. That's what we're working with here. So back to your metric system, which is bigger. So you get a 1 kilogram, has how many little grams in it? Does everybody know what we're doing here? King Henry died by drinking chocolate milk. So the kilo, 1 kilo has 1, 2, 3, oops, that looks like 2 H's. That's not 2 H's, that's 1 H. King Henry died by, this is the by here. Let me fix that so it's not confusing. King Henry died by drinking chocolate milk. 1000. Base unit is grams, so that's going to have 1,000 grams in it. Okay, all of that just to cancel out what? Grams. Okay, do we want to cancel kilograms? No, we want that as our final. I'm going to circle that so we know it's untouchable. Okay, leave that alone. Now let's go back to the beginning. We got milliliters here. Milliliters needs to cancel, right? How do I cancel? Do I put it on top or bottom of the next fraction? Because it's on the bottom now, so I'm going to put it on the top of my next fraction. So yeah, they're counter to each other. They're counter. One on bottom, one on top, they can cancel. And liters, you can see it up here in my final answer, has to be in the bottom, the denominator. So now decide which is bigger. Liter. So 1 liter is big. Has how many millis? 1,000 again. Okay. So this milliliter and this milliliter do cancel with each other because they happen to be opposite. And what unit remains? Yes, kilograms that are left and liters that are left. I'm not even going to calculate this, guys. Can you simplify? What do you see? You see 1,000 on top and 1,000 on bottom, right? So aren't they just going to cancel each other out anyway? That just happened to work out this way. I wanted to walk you through it, but this 1,000 and this 1,000, because they're the same number, cancel. So in the end, I don't have to calculate anything. It's 4.2 kilograms per liter. 4.52 kilograms per liter. Yeah, we did all that work, and you didn't have to actually calculate, but I wanted to show you that you could cancel something from here to here. Yeah.
Were you concerned if you could have figured out that both of the units are 1,000?
You could have. You could have, and you would have had to write me. Logically, people, you can do that. But I wanted to show you could practice that way too. Okay. All right, so we have just 3 minutes left. Let me show you 2 more types. Notice that this second set says 2 conversions. You don't have to stop the base. You can go directly from milligrams to kilograms or kilograms to milligrams, whichever way, just by doing that little 0 all the way across. You don't have to stop the base, but that's how this is going to model that. And then the very last one with the meters cubed and kilometers cubed and stuff, or squared, on your problem set, don't touch those yet. Okay? I'll do those with you on Tuesday some. All right? So what I'd like for you to do on your problem set 3B, where's that at? By the way. Online. I'm going to show you, if you have it in front of you, that's fine, but I'm going to show you the 2 or the couple sections you should be capable of. I just happen to have to pull it up first because, didn't have it pulled up for you guys here. So pack up, I'm going to show you the sections that you should be capable of. It's not going to be very much. So the flip notes are classification of matter, maybe I think a 15-minute video. That's online, I'll show you that as well. While this thing is creeping. If you feel like you want to know more before Tuesday, you can look at unit or chapter 3 in your book. But I also have YouTube videos galore. If you search INLO dimensional analysis, you'll see it. But I know that Monday we'll be doing more of this. Alright, so while that's pulling up, there it is. Oh, no, not yet. So right now it says finish some of problem set 3B and the flip notes on classification of matter. We're going to do a scavenger hunt on Monday or Tuesday. Okay, so make sure you know what the classification of matter is before Monday. All right, so problem set 3B. It's a beast, right? It's a beast. You can do mostly, you can do all of prefix conversions here. A, whatever that first section is. You can do some of these. The cubed and all that jazz, don't mess with those. But you can probably convert from meters to kilometers and seconds to hours. You know how many seconds are in a minute and an hour. Try those. Then, later on, we will be going through some of these word problems. Okay, the word problems are a little bit more difficult. You can maybe tackle the first 2 or 3. But after that, I'm going to make sure I work with you. And then as you go, there at the very bottom, there's answers to the problems. So pat yourself on the back every time you get one right. Okay, don't you guys have a sore back on Tuesday? Yes. So pat yourself on the back as you go. But answers only, totally not acceptable, right? So make sure you're showing your work for me on a separate sheet of paper. Alrighty. So I'm thinking the bell's going to ring, you know. Oh, I stopped us about 5 minutes early. Oops. So here we go. You are already packed up. I need you to go talk to somebody about what your nanotechnology project is on. You have 5 minutes. Go tell them what you're going to be working on. Nanotechnology investigation. Oh,